All right, so you might notice that this video looks a little bit different than ones in the past. There's two reasons for this. One is that this is based exactly off of the PDF that's provided for you as guided notes, which will hopefully be really helpful for those of you who are using it. If you're not using it, this might be an impetus to try it. So either print it or set up your own notebook. If you would really like to use guided notes and you don't have a printer, please be in touch and we can probably figure out a way to work things out. The other thing that's really nice about it is it just gives me more writing options than the old program did. I can't promise that we're going to use this forever, and I know that the quality is slightly worse on YouTube, but we're going to try this for the next little bit. So today, let's get ourselves started for notes. We're going to talk about graphing functions with transformations from Chapter 2, Section 4. Now, as you might guess, the first thing that we want to do is talk about what a transformation is. Now, a transformation is a way you can change the graph based on shifting it left or right, flipping it, rotating it, but it doesn't actually change the shape, just its placement. So the graph stays congruent with a transformation. Now, there's two main types of transformations that we're going to be talking about this unit. We're going to talk about translations or shifts, and we're also going to talk about reflections. So each of these has two types. And the first thing we're going to do is we're going to talk about the two types of translations. Now, there are horizontal and vertical. Now, you can tell that they are translations because they both have things being added and subtracted from them versus multiplied or divided or any other operation. So with shifts, when it's horizontal, that means that it is affecting the x because we're going back and forth on the x-axis. So a function will have function formulas all around it, and if it's a horizontal translation, the x is the thing being affected. Now you notice it's got the negative on there, and that's because horizontal translations go in the opposite direction as you expect, meaning that if I have an example here, x minus 3, we're actually going to go x positive 3 in this direction. So if I wanted to graph A, that is a horizontal shift, 3 spaces in the positive direction. So I'm going to take every point on this graph and just move it 3 spaces to graph A. So there's 1 point, 2 points. If I want to graph the other ones, they would all be here, and it's still, whoop, that one's slightly wrong. It's still graphing a parabola just 3 spaces to the right. Now, vertical shifts, like what we see here, or what we see here, are where we move the graph up and down, and that's where you have all the function stuff written here, and then this would be just plus 4. And for these ones, that means they're going to go B spaces directly up, just like you would expect them to go. Whoop. So in this case, it's 4 spaces up. They move the direction you think that they should. So if I wanted to graph this, I would take every point and just move, for part B, move it 4 spaces up. 4, 4, and you'll notice, once again, the shape is exactly the same. It's just raised. We're still looking at a parabola. Now, here you'll notice with part C is that we have a negative. We have a more complicated option. These are our reflections. So again, we're using this fun new system where we can scroll down. When you have a negative like this, that's a sign that you're going to look at some reflections. And there are two. There are across the x-axis or across the y-axis. And you can see that they're both created by having a negative, but it's just where the negative is. Is it negative and then the whole function? Well, then that's when it's reflected across the x-axis. Or if just the x part is negative and the function is all around it, that means that we're going to reflect across the y-axis because we're changing our values. Here we're changing our y values. Here we're changing our x values. So in the case of C, we have 2 different translations. we have the one that went up, so we're going to start with B. I'm just going to clear the board a little bit. So we have a little bit of a messy parabola for our +4. And then we also have this extra part, which means that we're going to reflect across the x-axis. So we'll take this whole parabola here and make it reflecting off of the horizontal line here. You can also imagine it reflected here and then went up. The operations order doesn't matter in this case. So it could be reflected like this and then scoot up 4, or it could scoot up 4 and then reflect over. And so in this case, we'll reflect across this horizontal line, and we get points here, 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 and here. And we would end up with this downward parabola like so. So you can have a couple different transformations, and you'll notice that the shape of this parabola is staying the same even if I am not the neatest grapher of all time. So, looking at number 2, write the function for the following above based on the transformation on the graph. So we notice that this is also a parabola, and we ask ourselves what transformations have happened. Well, no reflections have happened because we're still having this shape. We don't have one like this. I mean, perhaps a reflection over the y-axis, but that doesn't actually change parabolas because it would just go like that. So all we've got is translations. We have one that is taking us horizontally this way and then down. So actually, we're coming from the origin. That's where our original function would be, like this. And it's moving one space this way and 4 spaces down. So what that means is that if I want to write the function, if I wanted to write 4 spaces down, I would subtract 4 from the entire function. If I wanted to then go 1 space to the right, that would be x minus 1, because remember, horizontal shifts have the order we don't expect. Now this would be in transformation. We know that this generic graph here is x squared. So if we wanted to write the whole function out, we know that f of x is x squared, so this part becomes x minus 1 squared minus 4. So if you wanted to write it like this, you could. You could also expand out those parentheses if you wanted to simplify it, and you would end up with x squared minus 2x minus 3. So these are the 2 different ways that you could maybe write a parabola. Now, there's 2 other kinds of ways we can change graphs, but they are not transformations because they actually change the shape of the graph. And these are scalar multiples. So for example here, a scalar multiple would be where I'm multiplying by a constant on the outside, or again, constant on the inside. If it's here, it's a vertical stretch because we're taking every y value and multiplying it by 2, versus here where we're horizontally stretching, and we're actually, just like how the horizontal shift didn't really work the way we thought it should, here the horizontal stretch doesn't work the way we think it should either, because it's 1 over k. Think about inverse variation here. So then if I wanted to graph A with a horizontal stretch, what that means is that every y value is just going to be twice as big because we have a multiple of 2 here. So all the y values, f of x, are being multiplied by 2. So if I look here, my y value for this point is 1. So for my transformed graph, it would be 2. Here on my regular graph, my y value is 4. So my transformed y value would be 8. And so we can see that multiplying by 2 just makes it a steeper parabola like this. This video is getting a little bit long. These ones, here we'd be multiplying all of our x values by 1 over 2. So here all of our x values would be times 1/2. If you want to look at the graph for that, it's on the PDF. If you have other questions, please ask me in Zoom or in the private comments, and I'd be happy to talk to you as much as you want. Have a great day.